In this video, I'll be talking about a few asymptotes of this rational function. We have x squared minus 4x plus 3 over 2x minus 4. So the first thing we want to look at is the vertical asymptotes. The vertical asymptotes are those values that make the denominator equal to 0, assuming that you can't cancel this whole denominator out if you were to factor this numerator. It doesn't. You could check that on your own, but this would not cancel out, so we will have a vertical asymptote. And to find that, you just set the denominator equal to 0, so you say 2x minus 4 equals 0, and you solve that, and you get x equals 2. So our vertical asymptote is x equals 2. So I'll just label that. That's a vertical A for short, vertical asymptote. And then let's look at the horizontal asymptotes, any possible horizontal asymptotes. This does not have a horizontal asymptote. I'll just cut to the chase there. And that's because the degree, or the highest exponent on the numerator, is greater than the highest exponent on the denominator. That's an implied exponent of 1 there. So there is no horizontal asymptote. By the way, if they were equal exponents there, then you would be the ratio of 1 over 2. A ratio of the leading coefficients would be the horizontal asymptote, so y equals 1/2, if those exponents were the same. If the denominator had a greater exponent than the numerator, then the horizontal asymptote would be 0, y equals 0. But in this case, we have no horizontal asymptote. So I'll just write that in there. And again, to respect your time, I will just put no horizontal A for asymptote. Lastly, I'll put in the oblique or slant asymptote. And to do that, you're going to need to divide this, the numerator divided by the denominator. So I'm going to put that in and then jump right back. So in this division problem, I've got the quotient of 1/2 x minus 1. So you first find 1/2 x times 2x minus 4 equals the x squared minus 2x, and you subtract that, and you get negative 2x. And then you drop down the 3, and you say, well, you have to say negative 1 times 2x to get negative 2x. And so negative 1 times 2x minus 4 is negative 2x plus 4. You subtract all of that, and 3 minus 4 is negative 1 then. And that's a remainder. I can write that in there. The remainder won't do anything to the oblique asymptote. This is the big deal. This is our oblique asymptote. So I'll write that up there, and I should probably give you the full word here, asymptote. And that is y equals this 1/2 x minus 1. So there are all the asymptotes. And you can also find, find the y-intercept and the x-intercept, so you can sketch this graph of this. And I'm going to just put something in here real quick to show you what this graph would look like. And here you have it here. So this vertical asymptote of x equals 2, and this oblique asymptote, it follows this line. So the asymptotes are not part of the graph. They are simply just guidelines where the graph will not cross this, or I should say they tend toward this line. So vertical and oblique. We don't have a horizontal asymptote. And of course, like I said, you could find this x-intercept and this y-intercept as well to graph those. So there you go. And by the way, I should give credit to this. This is desmos.com because that is the program that I used. And I just punched it in, and it gave me this graph. It's really kind of a nice tool. So there you go. I hope that helps.